Hey everyone, just want to go over the second question in the exam one, part two review sheet for stat one. So this question is a regression question. It's asked studying data for time and hours for a sample of students spent watching TV during the weekend, and they had an exam on Monday and their test scores. Okay, so you can see here the Minitab output, which is very hard to see in the video. The Minitab output is here for the regression equation and the scatter plot and the correlation. Okay, so here in this one, it's a little cut off, but using the Minitab output, describe what you see in the scatter plot. So this is where we want to describe if there's a pattern, what's going on with y as x is increasing, and if there's any outliers. So here I can see that there's a linear pattern. We could see it's going in this direction like that. Okay, so I'm just going to say there is a linear pattern. And now I'm going to address what happens to y as x is increasing. So as x is increasing means I'm going to the right. So we can see as we're going left to right, y is decreasing. So as x increases, y decreases. And then I am going to address if there's any outliers, and I don't think I see any outliers. Remember, outliers would be something really kind of out of the way of this linear pattern, and I don't think there's anything. So I'm just going to say no outliers. Now remember, there's no measurement right here that I'm using for that. That's just based on the visual. So it's just my opinion based on the visual. All right. Now part B says, what is the value of the correlation for this data set? So this is my linear correlation coefficient value, that is R, that we're looking at here. So lowercase r. And this is given two places on the output. So we can see it right at the very bottom, which is very hard to see in the video, of the scatter plot, or for the Minitab correlation right here in this little table, it's right here. And so R is negative 0.757. Now, 757 is moderately strong. Remember, 0.8 to 1 or -1 to -0.8 would be considered strong. So it's just below the strong. So you could say moderately strong, or you could say strong or moderate. And I think any of those would be accurate. And we want to address the negative. So just remember when we're looking at R, this is the measurement that tells me the strength and direction of a linear relationship. Okay, so I'm just going to say there is a moderately strong negative linear relationship between, and now I'm going to use my context. So I'm going to say between weekend TV hours and Monday exam scores. Oops. I have my full context. Next, in part C, it says, what is the equation of least squares regression line? Now, this is given to me in my output from Minitab. It's right here at the very top, my regression equation. So it has it in terms of how I provided the data to Minitab, like the label. So it says test scores. I'm going to just write it with the y hat is equal to 892.82 minus 3.586x. Now, x represents the TV hours, and we want to know if that affects, or well, I don't want to say affects, if it predicts someone's test scores, my y. So interpret the slope of your regression line in context. So remember the slope is the value in front of x here. So this is my -3.586. That's the slope. So I want to interpret what's happening. So what I mean is what's happening to y as x is increasing. Okay. And it's this number. So I will say for each hour increase in TV hours, exam scores decrease, because it's negative, by 3.586 points on average. Squeeze that in there. Okay. So for every hour increase in TV hours, I'm expecting the exam scores to keep decreasing by the 3.586 points. Okay. Now the next one, part E, says how well does the line fit the data? This is my R squared value. So R squared is also given in my regression output here under model summary. It's the second one over. So R squared here we could see is 57.25%. And we want to interpret this in context. So, and then it says, should we be using the line for predicting? So we have multiple things to do here. So I'm reporting the value here. In context, remember, this is the percentage of that spread in my y that can be explained, okay? So I'm just going to write that out. I'm just going to say, well, 57.25% of, now the y, remember, is the exam scores. So exam scores, all right, it's of the spread of the exam scores. So it's 57.25% of the variation. I missed that very important piece here. Variation of exam scores can be explained by my equation, which is y hat equals 89.82 minus 3.586x. Okay. Now the last part says, should we be using the line for predicting? So that's that rule of thumb we're going to use as a 75%. So it's a no because R squared is not greater than 75%. If my R squared is greater than or equal to 75%, then we would say that it's a good model for predicting. All right, so what test score does the line predict for 6 hours of TV time? So I'm just going to plug that in here. So I'm going to rewrite this here. So 89.82 minus 3.586, and I'm going to multiply that by 6. So I have, let's see. So I have 89.82 minus 21.516. Okay, so 89.82 minus 21.516 gives me 68. I'm just going to keep the full answer, 0.304. If you want to round it to 68, that's fine. Since it is an exam score, and we're probably not having the decimals in there. Okay. So, is this prediction higher or lower than the actual test score for a person who watched 6 hours? So we would have to have the information, and I think I removed it from this paper, but I do have this information. So let me just look that up really quick, and I apologize, that's not on the paper here. So let me quickly find that so I can find that for you. So on the problem, if someone watched 6 hours, they earned a 65. Okay. So 6 hours earned a 65. So I'm just going to write it to the side so we can use that. So We're saying they're going to earn a 68, okay, here, just say 68 over here. So of course, 68 is above 65, so the prediction is higher. $68, okay, and then it says, what is the error? So remember, error is equal to y minus y hat. Y is my actual, so it's 65 minus 68, so it's a -3. Okay. That is question 2.